All right, class. Today we're going to look at section 4.4 in our notebook, and this is called Powers of Monomials. Powers of Monomials. Now, if you look at my example up here, did you notice that I have an variable raised to an exponent around parentheses raised to another exponent? I also am very good at calling this power to a power. Because if you notice, I have two exponents raised up there. All right, so let's see what happens when we have powers of monomials, or what I like to call power to a power. Now let's do what we did yesterday. Let's take my base. Do you notice there's parentheses? Who's inside the parentheses? That's right, x squared, and they want me to expand that 3 times, okay? So we've got x squared times x squared times x squared. Well, remember yesterday, we saw that if I have the same base, everybody's an x, what do I do to my exponents? I add them. What's 2 plus 2 plus 2? That's right, this would be x to the 6th. Now, does anybody see a shortcut already? We'll talk about it in just a second. Let's look at my second idea of how to expand powers of monomials. Who's my base? That's right, xy is my base. It's what's inside the parenthesis. And they want me to repeat that 3 times. So I've got xy times xy times xy. Oh. So what's going to happen there? Yeah, we're going to end up with x cubed, y cubed. Did you see that the same part of the base was repeated? And so that's why the base is in the parentheses cubed. So let's see, what could be our rule? What could be our expanded rule for powers of products? Well, if you notice, we're going to take the exponent on the outside and multiply it by everybody on the inside. So it's a to the m, b to the m. So if we've got a power raised to a power, we're going to see that we can multiply exponents. All right, let's practice a few while we've got a few minutes here. Okay, now notice, here we go. Recognize the parenthesis, who's in the parenthesis, and who's out of the parenthesis. So let's look at the first one. Now remember, we're going to take that cubed on the outside and put it to make that the exponent of everybody on the inside. So that means we've got -2 cubed and we've got t cubed. Now, here's where that list of perfect squares and cubes are going to help you. How would we simplify? What is -2 cubed? Well, -2 cubed is -8t cubed. Everybody understand what we did there? Good job. Okay, so let's look at number 2. We've got 6x cubed, and we're going to raise that to the second power. My base is inside. So here's what we're going to do. We're going to put that squared, that exponent, to everybody on the inside. So we're going to have 6 squared. What's going to happen to that x? Remember a minute ago we said if I have a power raised to another power, I can just multiply those numbers together. What's 3 times 2? And that's going to be 6. And so now I would expect you to be able to simplify 6 squared. 6 squared is 36x to the 6th. Let's look at our third example here. We've got 5a cubed b to the 4th, and we want to cube that. So remember, this cubed on the outside is going to everybody on the inside. So we've got 5 cubed. What's going to happen with that a? We've got the a cubed, and we're going to cube it again, so 3 times 3 is 9. And then let's look at b. What's going to happen with b? We've got b to the 4th, and we're going to cube that, so 4 times 3 is 12. Now, anybody happen to know what 5 cubed is? That's right, 125, a to the 9th, b to the 12th. Okay, now look very closely at number 4, okay? If you're looking there, and we're talking about simplifying this, did you notice, did you see it right here? We've got a cube with that first term. So we kind of need to do that first. Remember order of operation, PEMDAS, parentheses, exponents. So we've got to take care of that first. So that's going to give me 3 cubed. And then we've got p to the what? 3 times 2 is 6, q cubed. Now, what's 3 cubed? Well, 3 cubed is going to be 27. I'm going to push that out of there. So now we can multiply. What's 27 times 2? Okay, 27 times 2 is 54. We've got p to the 6th and p, which gives me p to the 7th. And when we look at our q's, we've got q cubed and q squared, which is q to the 5th. Now, again, we're in algebra, so it's a number thing and it's a letter thing. So I go ahead and take care of my numerical coefficients as I need to, and then I look at my same base and take care of exponents. Now, let's try a few more ideas here. Let's go to the next slide. Now, I put these on here because you've got some problems like this for homework tonight. It says find and simplify A, the sum, and B, the product of the monomials. Okay, so if I'm looking at number 34, and we're going to do A first, we're going to find the sum. Well, sum means we're going to add. So let's look. First of all, I've got to take care of that power to a power. So we've got A squared to the 6th power, which is going to give me a to the 12th. Remember, we multiply our exponents. And we're going to add this time, and that's going to give me negative 2 cubed a to the 12th. Everybody see what I did? I took that cubed on the outside, and I applied that exponent to everybody on the inside. Okay, so now let's see what we need to do. Remember, there's an understood 1 in front of that a to the 12th. What's negative 2 cubed? Yeah, that's negative 8. And then it's a to the 12th. Now, do we have like terms? Can we add them? We sure can. What's 1 plus negative 7? Well, I just told you the answer. 1 plus negative 8 equals negative 7a to the 12th. Now, on part B, they want me to take the product. This time, they want me to multiply. Okay, so I'm still going to go ahead and take care of my power to a power. So we've still got a to the 12th, but this time we're going to multiply that by negative 2 cubed a to the 12th. Remember, there's still an understood 1 there. And so now we've got, remember, this negative 2 cubed is negative 8. So we end up with negative 8, because negative 8 times 1. What's a to the 12th times a to the 12th? Yeah, that's a to the 24th. So see the difference? I really like this problem because it shows us in A what we do with like terms when we're adding. We just look at the numerical coefficients, and it shows us what to do when we're multiplying. Now, number 36, I'm going to get rid of this so we have some room to write. Number 36 is a little hairier, so let's see if we can look at it. Number 36, on part A, we're supposed to find the sum. So let's take care of the first term. We've got, now, this one's kind of tricky because we've got negative p q to the 4th. Well, because that's even, this is going to make that a positive term. So we've got p times p to the 4th, q to the 4th, which is going to give me p to the 5th, q to the 4th. Now, what happens when I take care of this on the other side? On the other term, we've got p cubed, and if I go ahead and square this, we've got 2 squared, which is 4, p squared q to the 4th. Everybody understand what we did? And now we're going to multiply so we can add. So we've got 4p to the 5th, distributive property here, and then p cubed times p squared is p to the 5th, q to the 4th. Now, can we add those? Do we have like terms? We sure do. We sure do. So we're going to see that there's an understood 1 in here, in front of here. So 1 plus 4 equals 5p to the 5th, q to the 4th. Now, let's see what happens when we multiply them. Let's see what happens when we multiply them. So, I've still got, this is letter B, so we've got p to the 5th, q to the 4th, and now we're going to multiply by 4p to the 5th, q to the 4th. So if I multiply those, well, the understood 1 times 4 is 4. P to the 5th times p to the 5th is p to the 10th. And q to the 4th times q to the 4th is q to the 8th. So a little bit complicated. You're going to have to slow down and be deliberate in your thinking. Now, I'm going to go ahead and move these so we can see my last 3 problems. Now, I threw these on here because they can give us crazy looking things, but as long as we know the rules, we know what to do. If you look at number 40, okay, we've got a power, a to the x, raised to another exponent cubed. So what do we do when we have a power raised to a power? That's right, we learn to multiply. So, ladies and gentlemen, what is x times 3? 3x. So we get a raised to the 3x. Now, I know that's super weird looking, but that's the rules. When I have a power raised to a power, I multiply my exponents, and that's the answer. Now, let's look at number 42. This time we're multiplying x to the n times x squared. Oh, well, what's the rule? We have the same base. Okay, if I have the same base, what do we do to our exponents? Yeah, that's right. We learned that a couple days ago. We're going to add them. So what is n plus 2? Well, that's going to be x to the n plus 2. I can't put these together because they're not like terms. So that's my final answer. Now, what's going to happen on number 48? Did you notice both of them have power raised to a power? So we need to take care of that. So we've got 2 cubed, and then we've got x, and that's going to be to the 3n. And we're going to multiply that times x to the 5n. What do we do now? Well, 2 cubed, I'm going to put the answer over here, I'm running out of room, is 8. Did you notice we have the same base, x? So we add our exponents. What's 3n plus 5n? 8n. So it's kind of weird to see letters and numbers as exponents, but it happens in algebra. All right, so now it's time for you to start your homework.